So here we've got a question on differential geometry. Now we've got a curve C is represented by the Cartesian coordinates of y equals cosh of x. And we want a general expression for the radius of curvature with that. Now, how are we going to go about finding that? Well, there's a general formula when we're expressing our curve in terms of Cartesian coordinates. And what we use is that rho equals, so we've got a fraction, so it's like a ratio. Now in our denominator we have the second derivative with respect to x, and in the numerator we've got a bit of an expression here which is 1 plus the first derivative, and we square that, and then what we do is with this numerator we cube it and take the square root. So it's the power of 3 over 2. So that's the general formula for a curve represented in the Cartesian coordinates. So simply all we have to do is to make sure that this function is always twice differentiable, and we need the first derivative and the second derivative, and then just plug into this formula. So let's go with that. So y equals cosh of x. So let's put our building blocks here. Y equals cosh of x. Now we need the first derivative. So the first derivative of this, dy dx, that equals sinh of x. And the second derivative, for the hyperbolic sine function, the next derivative of that is going to be cosh x back again. So d squared y dx squared equals cosh of x. Okay, right, let's plug this in and let's see what happens. Let's see where it takes us. So our numerator, we want 1 plus the first derivative squared. So that's going to be sinh squared x. And then that's cubed, and then take the square root of that cube. And then in the denominator, we want the second derivative, which is cosh of x. So this is all divided by cosh of x. Okay, now I'm not sure I want to cube that and then take the square root of it, because if I FOIL that out it's going to get a little bit messy. So there is a hyperbolic trig identity which we can use. So we know that cosh squared x minus sinh squared x, that equals 1. Now what we could do is get cosh squared x on its own. So cosh squared x, that equals 1 plus sinh squared x, and that looks just like our numerator. So we could substitute that for that. So let's do that. So that equals cosh squared x raised to the power of 3 over 2, so cubed and then taking the square root of, and then divide all that by cosh of x. Okay, right, now cosh squared x cubed, so let's look at that. So cosh squared x cubed, that is cosh to the 6 x, and then take the square root of that, so square root of cosh to the 6 x, that's going to be cosh cubed x. Okay, right, so we can simplify this off a little bit. So that's going to give us cosh cubed x over cosh x, and then that will simplify even more to cosh squared x. Okay, so therefore the general expression for the radius of curvature is cosh squared x. So that is going to be my answer for the general radius of curvature for a curve represented by y equals cosh of x. Now that's an interesting result there. When the curve is cosh of x, the radius of curvature is cosh squared of x. Okay.